do this, not with the electrode. So when we coupling the electrode in the center region, we shift the energy levels. And this shift is not simple to describe. We cannot say we just move up and down, because in the coupling, maybe sometimes we have a charge contribution, and this charge can flow for the left and right and can stuck on the part of the electrode. We never know what happened. So in nanodecol, you are able to plot the density of states, the projected density of states from the central region when you have the electrode coupling in each side. For example, in here, when we have this transmission, we have a lot of dips that is caused by this molecule in here. When we plot the p dose for the central region, we can point at that which is causing this dip is the molecule. And why this is important? In that case, it's important because we just saying that a funnel resonance is related with one side level in one channel. So if this dip comes from different parts of this molecule, we cannot point at that we have like a funnel resonance in here. That's why it's important to take the information from the density of states with the electrode, because we have to know how these levels will behave when we couple the electrode. And then when we have the gate voltage in the system, we can see in here that the gate shift the transmission that was in this point, and then when we apply the positive voltage, they shift for the lower energy, and when we apply the negative, they shift for higher energy. And once you have the transmission and you have the right point for this dip, you can take the energy and then analyze if with your gate voltage, your system can work with a spin filter. So with nanodecol, you have you can treat different systems and take care of a lot of physical quantity to analyze your system. And that was the message that I would like to talk today, and show that how nanodecol can be used to deal with this transport system. And I would like to thank the Impulse Technology, that our partner in this journey, and also thank you for attention and for having me here today. And that's it, my message for this seminar. Thank you so much.
Thank you, ma'am, for your insightful talk. Now we can have some questions from the participants. So participant can text in our inbox. We have 2 questions so far. One from Hemant. Madam, if we increase the electrode length by 2 times, around 8 Armstrong, maybe that he has mentioned A, and reduce the central region, will this affect the transport properties?
Yes. If you increase your electrode, for example, and your center region is small, I believe you will find a problem with the charge, because we have a long range to deal. It's much better if you are doing this kind of calculation. Reduce the length of your electrode and increase the center region, and deal with your calculation, increase the K point calculation in your electrode, and you find a better result for this calculation.
And one more question from Rajan S. Ma'am, can we simulate dual gate FETs?
Yes. Yes, you can. You put top and, for example, if your electrode, if your device is from left to right electrode, for example, and you can apply the bias between left and right. And also, you can apply the gate voltage on top and bottom. And you this dual gate in this system is completely possible on NanoDecal.
And ma'am, one more question. Ma'am, can we access the Hamiltonian file generated after the simulation?
Yes, NanoDecal object is a .mat file that you can open with MATLAB. And in our Fortran version, you also can access this. Your Hamiltonian will be always available for after your calculation. You can access this.
Madam, more questions are coming up. So
yeah, okay. I'm more than happy to answer.
Is it possible to calculate the activation energy for the gas surface reaction? And then one more question here asks, is NanoCal could handle the gas phase reaction too?
Okay. For this gas sensor, when you are okay, let me explain with an example that I just finished last month. For example, if you have a graphene structure and you put some molecule like glycine is one neurotransmitter that you want to investigate. And then you want to know how the glycine interacts with the surface. You can calculate the energy and energy absorption. And also you can calculate the transport through this. The TS calculation is not possible with NanoDecal, but you can calculate the charge interaction in your system. And you can also calculate the potential interaction. That is a very nice answer to evaluate how your system interacts with the surface. And you can also apply the light and incidence through the system and see if your sensor is sensitive to this light on NanoDecal. The only thing that you cannot do this is TS, but the other stuff for gas sense is available too.
And madam, one more question, madam. How to import CIF file or POSCAR file in Device Studio as the only .isZL extension is used in Device Studio. Like if we draw structure in VESTA, can we calculate its property in Device Studio?
Yes. For the sorry, I cannot show now because I will make a mess in here, but you can open the CIF exactly as you open on Vesta. You just, if you have your CIF file, you have just to take and left on the window, and they will open the CIF file. Is treat exactly like you do on Vesta. And you also can import any, for example, CIF and XYZ file from Vesta or Avogadro and open in DS without any problem. For do this, please try to use our trial version and try to build a device. And if you find any problem, just go to our forum and ask, and I will help you by myself how to do this kind of calculation, how to do the build of the system. But it's like you are doing in Vesta.
Madam, more questions are coming up.
Yeah, it's okay.
Is it possible to import the Material Studio files to Device Studio for further device-related studies?
Yes. The device, you have the HWZ file for device, but you also can export the CIF file. And once you have your CIF file from the electrode and center region, you can use for any other code that you have. It's possible to export and import for Device Studio.
Madam, more question. So what all semiconductors we use in nano, decal, or for example, will it use ZNO for photodetector?
Okay. With the semiconductor, we always worried about the band gap. So for now, we still working in hybrid Z functional to deal with the band gap. But the best that I knowledge, there is no code for transport calculation that has the hybrid Z functional. So for semiconductor, you will have this transport with this gap difference from experimental, from LDA and GGA, but it's possible to treat the semiconductor for gas sensor as well.
And Madam, one more. Is it possible to model nanostructures for of only graphene
Yes.
WSE2 or any other 2D nanostructure of other materials possible?
Yes, or whatever you want to create with Device Studio, you are able to do this. Even if, for example, you can use the metal electrodes or metal surface like gold, silver, copper, or you can use only graphene and only graphene nanoribbon. I cannot show you right now. Sorry, I have some limitation with my connection here, but. However you want to build, you can do with Device Studio. And also, we have in Device Studio, if you go in our tutorials, there is I don't know if I can show you right now, but sorry, I cannot show you right now. Let me see. For example, I will share my screen. Just can you see? I will turn off my camera and share my screen. Can you see my screen?
Yes. Yes.
Okay. For example, if you go in our web page, NanoDecal, and then tutorials, we have these tutorials in here. For example, for graphene. For this graphene, we have this pin device, this zigzag graphene nanoribbon. If you go in here, we have a device from the graphene nanoribbon. And in here, you will find every step and how to build the structure. For example, which window you have to pop up, and how to replicate your system, how to redefine your Unity cell, and how you create your device. And you can do the same for graphene. And then here we teach how to do a SEF electrode calculation step by step. And we have this image that help you to, it's almost like a hands-on, but you will be in your time. So you can take the time wherever the time you need for do this calculation. And also we provide the input files and this documentation, and then you can follow and create. And we have a bunch of materials in here. For example, for this spin device, we have a combination of nickel and graphene interface, something like this. And you will see that it's possible to make an interface between our organic and metal system. And we teach how to build this organic with metal, and also how to create the structure and how to make this calculation. You can go in these tutorials and follow we have a different example for different structure. Okay. I don't know if I answer your question.
And thank you, ma'am, so much once again.
Thank you.
Madam, you have responded a lot of questions from our participants. And
Please,
with
I have
this,
time. If you have time, I'm more than happy to answer all these questions.
right now, I think there's no more question, madam. You win.
Okay. Okay. Thank you.
With this, we have come to in our first day of the workshop. Finally, we'd like to thank all the today's speaker and participants for putting up such a great contribution for this workshop. So
Okay. Thank you so much.
good night, ma'am. For announcement for our participants, tomorrow morning 10:30 we'll assemble here again. Thank you. So much and good night. Participants.